Just turning it back. All right, this is chapter 2.2 if you want to put a heading on there. I'm gonna do a little diagram here. We're graphing parabolas. If the parabola has arrows going up, your vertex is the most center point, and your vertex will have a minimum. Vertex. And then I'm going to do another one over here. Sometimes your parabola opens down. The center point is a vertex, and in that situation, that vertex has a maximum. And that can be a little counterintuitive. People think, oh, arrows are going up, maximum. However, what it has is a low point. We call that low y value, a minimum. And this one, that's like a hill. We call that high y value, a maximum. So it's like a bowl and a hill. Minimum, maximum. Well, vocab. The line of symmetry or the line of reflection right through the center, that's called the axis of symmetry. And all of the points reflect across that line. All parabolas are perfectly symmetrical. This formula is so helpful. It'll tell you the center. It'll tell you what the axis of symmetry is. So we're really grateful to the mathematicians for coming up with this formula for that center line. The only thing about it is the way it's typed with the negative in the middle. Sometimes students think like, oh, are they both negative? What's negative here? So if you want to rewrite this, it's the top you think of as negative b, and the bottom you can do 2 times a. So I don't like to have a negative in the middle of the fraction bar. You can think about it as negative b over 2 times a. Same thing. And then the last piece of information in this top box is that c, that's that last value, it's a constant, is the y-intercept. In a linear function, the y-intercept is called b. In a quadratic, it's called c. Right, when we break down all the requirements for this content, it's a lot. Look at these directions. First, it says determine the y-intercept, the c value. Then it says do the equation for the axis of symmetry. Oh, okay, that's the formula. Then it says find the vertex. Oh, the center point. Also, you're asked to do domain and range. And then lastly, you graph. So there's a lot more involved here. It's not just make a graph. You have to do all these different criteria. Step 1, identify A, B, and C. This is our first equation. A, B, and C go in order. This one's kind of basic. We don't see an A value. That means there's an invisible 1. A equals 1. Nice. Right in order, 1, 2, 3. That's going to change in every problem. So that means 0, 3 is the y-intercept, so we'll put a dot right there. So far, so good. All right, next we're going to do that equation for axis of symmetry, the negative b over 2a formula. I guess I just got done saying I prefer it with the negative sign up top. Doesn't really matter though. That's right, it's equivalent. As long as you don't put it on the top and the bottom. That's the no-no. So this would be negative 2 over 2 times 1. And get out that TI-36 calculator because there's a lot of negatives involved here. And just really, you're welcome to do it by hand, but it's just great to have that calculator out for these fractions. So you have a full green light permission to hit that fraction button, negative 2 up top, 2 times 1 down below, and just get it done precisely. It's so often I see students that they have the process down, but their numbers are wrong. And it's mostly because of one negative sign is messing them up. So if you want to prove, the process, it's nice to have your arithmetic right, your math right. So just do it by hand if you want, put in the calculator if you want. All right, so I'm going to do it by hand, but you feel free to click away. You don't even have to show all this work I'm showing. This answer is negative 1. So x equals negative 1. We're going to show for the axis of symmetry, and a lot of times I'll call that AOS. So let's put a dash line at negative 1. And that'll be our line of reflection. Okay, so it's like step 1, step 2. Are we ready for step 3? All right, we're gonna find the vertex now. That vertex will always be on that dashed line. So where's the vertex? The x value of the vertex is negative b over 2a. To determine the y value of the vertex, plug negative b over 2a into the function. So I'm gonna write that out more clearly. Plug in the answer from step 2 into the problem. So the answer that you just got, that negative 1, we're putting it in here into the actual y equals equation. We're going to put it into these x's, and that's going to tell us y. So you plug in that answer to the problem. So our equation is x squared plus 2x plus 3. So we're going to put a negative 1 in there. And your calculator can save some time here as well. You don't type in the y equals, but I'd love to see you guys getting like really proficient and efficient in parentheses, negatives, exponents. What I don't want to see is you guys hitting enter more than once. This should all be typed in together at the same time. So that's a way more advanced calculator than you used in geometry. It will do all of this at once. And you can see it all. It'll look exactly like this. You hit enter. I'm going to do it by hand, which you're welcome to do, but there is real value in getting good at that calculator. I got 2. If you used your calculator and did not get 2, let me know. If you got an error, a lot of times that's because you're putting a minus sign where there should be a negative sign. That's an easy fix. If your number's coming out wrong, A lot of times it's because of the parentheses. That's also an easy fix. So sometime in class today, just call me over, bring your calculator to me and say, hey, my numbers aren't coming out the same way, and I can just show you a couple little tricks so that you get really accurate on this. All right, so we put the -1 in, that was the x value. We got a 2 out, that's the y value. Go ahead and plot it. It's on the dash line. -1, comma 2. X, comma 1. The line of symmetry is a line of reflection, so we could reflect this over right now, and then we pretty much can see our parabola. So if you want to reflect the y-intercept over, you're always welcome to do that. You're required to get 5 points. We already have 3. Questions? How do I get the other 2 points? We're going to go on to step 4, and we're going to make a table. Big long table. The table will be different for every equation. The key about making the table is that the center point is the vertex. So I'm going to take this point I just got, which is the vertex, and I already know it. I'm going to fill it in, shortcut. I don't want to do another point when I already found one. We did all the work for that one. It's the center of the parabola. Put it in the center of the table. Already done. From there, you need some points that are lower than the vertex and some points that are higher. So just count up and count down, pretty much. So, what? -2, -3, 0, 1. So that'll change. The x values aren't the same for every quadratic. You figure it out. Lower, higher. And so we're plugging all of these into the problem just like we did the vertex. So I'm going to do -3 squared plus 2 times -3 plus 3. -2 squared plus 2 times -2 plus 3. 0 squared plus 2 times 0 plus 3. 1 squared plus 2 times 1 plus 3. The good news is that your calculator has a copy-paste feature. You can select it, copy, and paste it. So you don't have to type it out 4 times. You type it in once, you copy and paste it, you go up, you highlight it, and then you just change the number in parentheses. So I don't want to see you typing that out 4 times. You type it once, and then you highlight it. So you use the little circle button to go up, highlight, hit enter, and then you cursor over and you can change the number in parentheses. And then you're really efficient, and then you're not running out of time. You're doing it quickly. Do we have a calculator on like the exam? This calculator is approved for the SAT. It's approved for every test in this class. It's approved for ACE Math 1. It's approved for the AP Calculus. This calculator is allowed on everything from here on out. Half the SAT is no calculator. Other than that, you can use this calculator on anything. How do I copy it again? You cursor up till it's highlighted, hit enter, and it brings the problem down, and then you just go over and you put in the new x values.
Teachers, pardon this interruption. Students, if you own a black GMC Sierra pickup truck parked near the baseball field, please report to the front office with your keys. Once again, students, if you own a black GMC Sierra pickup truck parked near the baseball field, please head to the front office with your keys, please. Thank you.
Okay, and then you're also welcome to, do it by hand. But both skills are important. You want to be efficient and proficient in a calculator, and then if you want to do it by hand, you go that route as well. Well, we already did 0, didn't we? That's the y-intercept, so that one we already had done also. And then here's our ordered pairs. Let me know if you get an error in your calculator. I know just what caused that. Let me know if you got a wrong answer in your calculator. I know just what caused that. And I don't want that to happen, so let me know. Let me know if you get a wrong answer by hand. I probably know what caused that as well. When you're ready, plot your points. Should make a nice U shape. Now, because there was an a of 1, this parabola is congruent to the parent function. So if you were one of the students who understood starting from 0, 0, and then going over 1, up 1, and over 2, up 4, that's still true here. So once I got the vertex, I could have just drawn it, knowing that there was no stretch, shrink, or reflection over 1, up 1, and over 2, up 4. All of that holds true from last chapter here with regards to A. Sorry, I can zoom back out. I think the last thing we have to do here is talk about domain and range. The domain is x values, and these arrows go up and out forever. They should never go straight up. A parabola never goes parallel. It always goes a little bit out, and it will go infinity left and infinity right. So the domain of this quadratic equation is negative infinity through infinity. The range talking about y values is a little more complicated. When I swoop down on this parabola, let's say I'm reading it from left to right, I'm decreasing, 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 flatten out at 2, turn around, increasing, 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 increasing. Never goes below 2. So when I think about the y values, I have to think, okay, the lowest y value is 2, but then it arrows up to infinity. So unless it's a word problem, all of your parabolas have a domain of all real numbers and a range of 1 endpoint and 1 infinity, which is it, swoops and turns. All right, you flip this over. We're just going to practice these steps all over again. I did kind of summarize the steps here for you because the front is like in depth. This is the process you want to remember. So step 1, consider A, B, and C and plot C. Then you have your formula. You plug that answer in, and then you make a table. So here's the steps shorthand. If you want to just jot down instead of use the front as a resource, but I know it's annoying to flip back and forth. So, all right. So you guys get at it and let me know what questions you have. Yes. So tiring to do now. When B is 0, there's no left or right shift. So that's only an up and down transformation. So if there's no B, it's centered right on the Y. It'll be a little easier. Yes. Yes, sir. Yeah. If your B is negative, it'll go positive in that formula. So use the other formula. Like, yeah. Thanks. Oh, okay. All right, very good, very good. Yeah, because I have this one here. And then so whatever square I made, so 0 is they can figure it out. Some people won't know all year. It's so sad.
You walk me through the stuff. This one. I'm still finding it. What I need to run here? Do I need to find like these things? Wires that were this thing I can. Okay. The first X value for negative stuff. You're right. My friend borrowed it. I can get it back. You're right. I don't remember. There's so many things. So. Yeah, like, it's probably wrong. Rock probably doesn't like that. Okay.
All right, if you got x equals -2, well done. If you wrote +2, just fix it. It's not that big a deal. Think about your negatives. Just fix it. So our dashed line is at -2.
Are you cutting my twos?
No, I'm not going to count by 2.
Yeah. So you cutting my twos?
I'm going 0, -1, -2.
I did -8, -4. Then. Wait. I mean, if you do score. How do you?
As long as you recognize it's a stretch of 3.
I wish. No, you just can't. Like you just.
What about now?
Oh.
So how do you start the graph, or not the graph, the table.
I put in the middle. And then up to -1.
Homework.
Yep.
Hey, is it -2, 4? Yeah. Boom. Oh, she just did that.
Negative -2, -4. Okay, this one was X values that. Those are my values. Those are my y values. Where do you put? No, that's one. That's why it's fun.
Oh, you don't have calculator. That makes sense. George, you actually have a calculator. Then why still just telling me that?
We were just talking about communication skills, and the people you set up to take this next storage from.
So you're saying it's me.
Correct.
Well, I got 55. I'm gonna do that.
Pointy. So just try to curve it. Is anybody ready to talk about a stretch of 3?
No.
I think Olivia might be.
Wait, I'm trying to. You have your y value is -8, 1, 4, 1. Yeah, I know. Okay.
Oh, that makes sense.
Okay, so normally it would go from the vertex over 1 down 1. This one goes over 1 down 3 because of the 3 in front. And then instead of over 2 down 4, it goes over 2 down 12 because 3 times 4 makes that distance 12. So I see the stretch at 3 in this, just like I did in the transformations last chapter.